Okay, recording is starting. All right, so I've already covered everything I need to cover for the exam. This coming Friday is our next test. So I'm going to get started with 10.1. I'll do 10.1 today and tomorrow. And since none of this is going to be covered on this coming exam, I can probably finish early today, probably finish early tomorrow. Wednesday's a flex day. That's a CSM holiday, so to speak. So no classes. Thursday, buffer day, I will let you ask questions about anything from 8.1 through 9.3, and Friday's the next test. And you should know the rules by now for exams. Okay. So I'm starting 10.1. 10.1 will not be on the test. The exam on Friday is 8.1, 8.2, 9.1, 9.2, 9.3. Okay. Again, I tend to give about 10 questions. There are 5 sections, so the most likely scenarios I give 2 questions from each section. Okay, but I'll get started with chapter 10. All right. And I have finished grading the quizzes from last Friday. I sent you an email and I sent the video on the solution. So you should have gotten it. If you did not get that from me, then email me back about why didn't I get that. But I believe I've finished with all the quizzes, and you should have gotten an email from me sometime over the weekend about last Friday's quiz. Okay, so I'll get started with 10.1. Go ahead and take notes, but this will not be on this Friday's exam. Okay. All right, so 10.1 is in something called parametric equations. Page 640, curves defined by parametric equations. What's going to happen is that you have stuff that looks like this. X is a function of t, y is a function of t. T quite often is time. That's the most likely scenario. But we'll have situations where x and y are functions of theta, let's say, where theta is an angle. Okay. And we're going to graph equations like this. This is a heavy topic in Calc 3. Those of you going on to Calc 3, in 3 dimensions, you'll have quite a bit of parametric equation stuff. Okay, so what's going on? So here's an example of what we're up against. X is a function of t, y is a function of t. So is there a relation between x and y? Well, maybe you can eliminate the t and then have something with x is a function of y or y is a function of x. But even if you're not able to, you can make a table. Okay, so you plug in different values of t, plug in to find x, plug in to find y, and then you just ignore the t and graph x versus y, although you can think of t as time. Okay, so all they did over here, and that's all that's going to happen here, is you can pick a t, plug in for x, pick a y, plug in for y, think of it as time, and just kind of cover this up and plot x versus y. So then these are just plotting x versus y, and t can be thought of as a passage of time. So as time goes by, this is what happens to the point. It looks like it's a parabola in this particular case. Okay. That's basically the idea behind section 10. Okay. And just thought I'd mention to you, I'll do this after next week, but there is a couple of sections on something called polar coordinates. Section 10.3. You'll need special polar graph paper for that, and I want you to use the exact graph paper that I'm going to ask you to have. Some of you may have done polar graphs before, some of you haven't, but there's one particular one that I want everybody to use so it can be uniform, and I'll be grading you, in a uniform fashion. So please don't use your own polar graph paper. Some of you maybe have experience with polar graphs in the past. If you do, great. You got to use the graph paper that I give you. Okay. All right, but that won't be until 10.3, which is next week or the week after we take the test. Okay, so let me go ahead and get started with 10.1 and show you the homework as usual. So it's on page 645, and the homework was 1 to 21 odd. And as usual, I'll do a bunch. So again, for the homework, there's a 70% homework requirement. That's really a joke because I do sometimes 70% of the homework, or if I do less than that, 40%, 30%, that means you only have to do a little bit extra. Just copy what we did in class and you go on from there. Okay, so 1 to 21, let me show those to you right now. So again, it's on page 645. So those of you who don't have the book and aren't getting it, there's that. Gonna have to angle the book, sorry. Doesn't fit because this arm is in the way. Maybe I'll go like this. Try this, except I lose focus there. Okay, so there's 5 through 8. And it's a little bit out of focus, but hopefully you can read it. If you're not sure, ask me. Okay, then the next page. Let's see, 19 and 21, and there we go. All right, so you notice for these problems, they give you x as a function of t, y is a function of t, and well, it looks like 1 and 3, they tell you t goes from whatever to whatever. Sometimes they don't tell you, in which case you can make up your own and go from there, okay? All right, so let me go ahead and start showing you some of these problems. Okay, number 1, x equals 1 minus t squared, y equals 2t minus t squared, t goes from 1 to 2. All right, so are x and y related to each other? Well, they're both related to t. So since they're both related to t, they're sort of related to each other. Now, how can I figure out what the graph looks like? Well, just like in algebra 1, I can plot t versus x, right? And then I can plot t versus y. Then when I'm all finished, just cover up the t and plot x and y. Although you can go back and think of t as time. Okay. All right, in this case, it says t goes from -1 to 2, so no big deal. So cover this up. Just look at this. So plug in -1, x is 0. Plug in 0, I get 1. Plug in 1, I get 0. Plug in 2, 1 minus 4 is -3. Okay, so you're all very good at that. Then I plug in here. So kind of cover this up. T versus y. Plug in -1. Let's see, plug in -1. That'd be what? -2 minus 1 is -3. Plug in 0, 0 minus 0, 0. Plug in 1, 2 minus 1 is 1. Plug in 2, 4 minus 4 is 0. Okay, both very easy. And now to plot the points, just cover up the t, and this is very easy, right? So 0, -3, -1, 0, 0, -1, -3, 0. There's the graph. Okay. Almost looks like a sideways parabola. Okay. And then the directions also say sketch with an arrow the way it's curving as t increases. So here t was -1, 0, 1, and 2. So it's curving this way. So see these arrows here? So it's not just a graph, it's a direction graph, meaning as time goes by, if t represents time, as it normally does, I'm going this way, from here to here to here to here. Okay, so no big deal. All right, that's all there is to it. Should be pretty straightforward. So that was number 1. I'll let you do number 3, which is similar. And then number 5. Sketch the curve by using parametric equations to plot points, indicate an arrow, blah, 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 blah. And then eliminate the parameter to find a Cartesian equation of the curve. By the way, you see the word Cartesian. What's Cartesian? That's x and y. So the rectangular coordinate system is sometimes called the Cartesian coordinate system, the regular x versus y that we're familiar with. That's sometimes called the Cartesian plane, the usual x and y. Okay, so I'll do 5, which hopefully shows you how to do 7. So x is that, y is that. Now, unlike the first one I did, they told me t goes from -1 to 2. So what do you do if they don't tell me? Well, make up your own. So I decided to just go from -2 to 2. It's arbitrary, but to be fair, you pick, positives, negatives, and 0, but, somewhat nice. All right, so I decided to go from -2 to 2. And you plug in. When we look at this, plug in -2. 2 times -2 minus 1 is -5. Plug in -1. 2 times -1 is -2 minus 1 is -3. Plug in 0, -1. Plug in 1, 1. Plug in 2, I get 3. Okay. And then I do this. Half t plus 1. Okay, so plug in -2. 1/2 of -2 is -1. Plus 1 is 0. Plug in -1. -1/2 plus 1 is 1/2. Plug in 0, 1. Plug in 1, 1.5. Plug in 2, 2. And then I just graph this. Right? Really no big deal. -5, 0. -3, -1/2. -1, 1. 1, 1.5. 3, 2. Arrows going this way. Looks like a straight line. Can I prove it's a straight line? In this case, yes. So the second part of the problem, part B, eliminate the parameter. So what's parameter? T. It's the extra variable, right? We're used to having x and y. So what's this t stuff, right? So t is called the parameter. It's an extra variable. We're trying to get rid of it now to find a Cartesian equation of the curve. That means just x and y, no more of this t stuff. So how do I get rid of the t stuff? Well, normally you try to isolate t. So a little bit of algebra here. If I add 1 and divide by 2, it looks like that, right? Look, add 1, divide 2. That's t. So now I pick this up and plug it into here. So that gets rid of the t. That eliminates the parameter, the extra variable. So y is 1/2 t plus 1. So here it is, 1/2 t, there's t, plus 1. A little bit of algebra, that's 1/4 x plus 1/4 times 1 is 1/4 plus 1, 5/4. Do the algebra. 1/4 times x, 1/4 x. 1/4 times 1 is 1/4 plus 1. So y equals 1/4 x plus 5/4. And yes, indeed, I recognize that as y equals mx plus b. So that does indeed prove that it is a line. So when I just plotted the points by making this table stuff, right? I look at it and say, oh, it looks like a line. Now, truly, indeed, it is a line. No question about it. Okay. All right, so that's the way that one goes. And now let me show you. Nine. X equals square root of t, y equals 1 minus t, number 9. All right, this time I cannot plug in any negatives, right? Now the ones I just did, there were positives and negatives. Here I can't. And also there's a square root, so I don't want to take like the square root of 2 or the square root of 3. So I picked nice numbers. Notice I picked 0, 1, 4, 9. this doesn't bother me a whole lot, right? I can plug in any integer. But here, because there's a square root, I pick 0, 1, 4, 9, because they have nice square roots, right? I don't want to pick 2, square root of 2, I don't like it. Square root of 3, I don't like it. 4 is good. Don't like 5, don't like 6, don't like 7, don't like 8. Square root of 9 is good, right? So that's why I picked these numbers. And yeah, these are easy. Just give me the square root. 0, 1, 2, 3, right? Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. Mind you, you're not allowed to plug in any negatives, right? We're not doing any of the imaginary stuff in this class, right? None of the I business or complex numbers, right? Just real numbers. Okay, y is 1 minus t, so cover this up. So 1 minus t, 1 minus 0 is 1. 1 minus 1 is 0. 1 minus 4 is negative 3. 1 minus 9 is negative 8. Okay. And I graph those. Okay, so in green here, if you can see the green, so 0, 1, 1, 0, 2, negative 3, 2, negative 1, 2, 3, and 3, comma, negative 8. Right. So in green, if you can see the green, it's curving down like so. Now what's all this other red stuff? Okay, so it said eliminate the parameter. So to eliminate the parameter, I need to solve for t. Good way to do it is get rid of the square root. So right here, if you square both sides, right? If you square both sides, it says x squared equals t. Agreed? Square. X squared equals t. So now I have y equals 1 minus t, 1 minus t, but t is x squared, so y equals 1 minus x squared. So that's the graph, sort of. Now, if the problem started off with just this, right, then I would have said, oh yeah, parabola opening down, vertex is 1 above the origin, so 0, comma 1, right? So separate from everything else, if all I saw is y equals 1 minus x squared, I would graph this, right? Because I remember y equals x squared, U-shape. Negative x squared, upside down U-shape, concave down, as it were, right? Remember concave up and concave down from Calc 1, right? This would be concave down. And then the 1 moves the whole graph up 1. Okay. So the red and the green combined is this whole graph. However, I went ahead and crossed this out because this part's not really there. Okay. So the real graph is just in green. So how come I don't have that? Because the original problem is, where'd it go? Is this. It is not this. The original graph was this, and you can tell you're not allowed to have any negatives for x because you can't take the square root of a negative. So even though my analysis came back with y equals 1 minus x squared, this part's not really there. Okay. So that's what I have. Okay, and then 11 has some trig to it. So what happens when there's trig? All right, eliminate the parameter to find a Cartesian equation of the curve, sketch the curve and indicate with an arrow the direction in which the curve is traced as the parameter increases. All right, so for 11, I see a function of theta, right? X is sine half theta, y is cosine half theta, theta going between negative pi and pi. Okay, so what's up with that? Right? Okay. So let me show you this. And by the way, I'm pretty much done after this one. I have time for tomorrow to do the rest of the problems. Okay, and it's just barely past 8:30. So if anybody wants to ask any questions for review, probably not for this stuff, but for chapters 8 and 9, you may. Otherwise, we're going to end fairly early today. All right, how do I eliminate here? I got sines and cosines. I want to take advantage of the fact that sine squared of some angle plus cosine squared of any angle is always equal to 1. Okay, so I have sine half theta, cosine half theta. So what you do is you square both sides. X squared is sine squared half theta. Y squared equals cosine squared half theta. Then what you do is you add them up. X squared plus y squared. So what do you want to do that for? Because that's going to give me sine squared half theta plus cosine squared half theta. Well, sine squared of any angle. Half theta is an angle. If theta is an angle, half theta is also an angle, right? Like if theta is, I don't know, 50 degrees, half theta is 25 degrees. It's a legitimate angle. So sine squared of whatever angle plus cosine squared of the same angle is equal to 1. Which tells me I have x squared plus y squared equals 1. That's just my unit circle. However, I may not have the entire unit circle. It all depends on this. So that's where I have to make a little table based on that now. So I'm going from negative pi to pi. So I make a little table, negative pi over 2, 0, pi over 2, and pi, and I plug in. Okay, so if I plug in negative pi, I'm taking the sine of negative pi over 3, negative 90 degrees, the sine is negative 1. If I plug in negative pi over 2, half of that is negative pi over 4. Sine of negative pi over 4 is negative radical 2 over 2. Plug in 0, half of 0 is 0, sine of 0 is 0. Positive pi over 2, whoops. Plug in pi over 2 here. I'm taking the sine of pi over 4. Sine of 45 degrees is radical 2 over 2. And then if I plug in pi, I'm taking the sine of pi over 2. That happens to be 1. So I fill this out. And now to fill this out, look at this. Cosine half theta. So same thing, plug in negative pi, cosine of negative pi over 2, cosine of negative 90 degrees, 0. Plug in negative pi over 2. I'm taking the cosine of negative pi over 4. That's positive radical 2 over 2, fourth quadrant. Fourth quadrant cosine is positive, you might recall. 0, half of 0 is 0. Cosine of 0 is 1. Okay, right here on my unit circle, right? You're right there, x coordinate is 1. Plug in pi over 2. Half of pi over 2 is pi over 4. Cosine of pi over 4, radical 2 over 2. And plug in pi, whoops, pi, I'm taking the cosine of pi over 2, cosine of 90 degrees, x coordinate up here, back to 0. Okay, so here's how we traverse on the unit circle. I'm on the unit circle, but I'm not going in the traditional fashion where you start over here, right? And then you go counterclockwise. Looks like we're going this way. See, how do you know that? Well, I just plot the points. Negative 1, 0 is there. Negative radical 2 over 2, radical 2 over 2, that's second quadrant, that's up here somewhere. 0, 1 is here. Radical 2 over 2, comma, radical 2 over 2, that's over here. 1, 0. So I'm not going the traditional route where we start over here at 0 degrees or 0 radians and go counterclockwise. Looks like we're starting at negative 1, 0, and we go clockwise half a circle. So even though we're on a unit circle, we're going different than normal. So this tells you how we're traversing our path. Okay, I'm starting here, I'm ending here, and I'm going in a clockwise direction in this particular case. Okay. And that's basically what's happening, folks. So I've done just about half the problems. I showed you one, you did the other. Going to show you another one, you do the other, right? So I believe I did 1. Problem 1, you tried 3. I did 5, you tried 7. I did 9, and well, there's no other one like that. And I did 11. Okay, so next time, tomorrow, I'll do some more and pretty much finish up the section. But again, anything that I covered today and tomorrow won't be on Friday's test. And that would be it. Okay. So next time I'll start off with problem 13. Tomorrow I'll start 13. Again, my advice is don't even look at any of this until next week. And go ahead and look at the video later or have your notes, but don't look at it for the test. That will be word for the next test. Okay, but tomorrow I'll start with 13 and continue from there. Okay, but otherwise I'm finished, folks. So let me stop the share and check the chat. And if nobody has any questions, then we're going to call it a day already. Okay, so whoops, stop here. Where's the chat? All right, so any questions? Otherwise, we're going to quit. All right, have a good day, everybody. We'll see you next time. Okay, bye. Take care.